Today we are going to talk about something called combinations and permutations. We referred to permutations a little bit yesterday, but we're really going to talk about them today more in depth, and we're also going to add something called combinations. So let's look at our warm-up first, um, because this will give us a good springboard into what we're going to be doing. So we're making partners for our next partner quiz. I have 4 students remaining, and I'm deciding how I could pair them up. The students' names are Ashley, Brian, Charlie, and David. The first student in the pair will get a blue quiz, and the second student will get a pink quiz. In how many ways can I pair these students? List all the possibilities below. So it says the first person gets a blue quiz, so I could have Ashley get a blue quiz, or I could have Brian get a blue quiz, Charlie a blue quiz, or David a blue quiz. So if Ashley gets a blue quiz, that means I could have Ashley pair with Brian, Charlie, or David, and Ashley would get the blue quiz, Brian would get the pink one. Ashley could get the blue quiz, Charlie could get the pink one, Ashley could get the blue quiz, and David could get the pink one. Now, if Brian got the blue quiz, then that means we could have Ashley with the pink one, we could have Charlie with the pink one, or David with the pink one. If Charlie got the blue one, well, Ashley could get pink, Brian could get pink, and David could get pink. Or if David got the blue one, we could have Ashley with the pink one, Brian with the pink one, or David with the pink one. So we have how many different combinations? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 different combinations that we could have. Or you could have said, wait a minute, yesterday we learned, well, we have 4 options for the first partner and only 3 options for the next one, and we get 12. Okay. So in this one, order mattered. It mattered who got that blue quiz because the other person in the pair got a pink one. Now in letter B, both students get the same quiz. So what I'm going to do is we'll just pick a color. Let's pick blue. And I'm going to write the same thing as I did above, but with blue quizzes. Okay, so I'm just going to copy this down quickly so we can see how things change. So since they are all getting the same color quiz, does it matter if Ashley was first and Brian was second, or if Brian was first and Ashley was second? They're both getting the same color quiz, so it doesn't matter. It doesn't matter that Ashley got hers first and then Brian did, or if Brian got hers first and then Ashley did, because they have the same quiz, the same thing. So I'm going to get rid of my repeats. I have A and B here. That's the same as B and A, so I'm going to cross this one out. So I'm just crossing out all of my repeats. Well, Charlie and Ashley, that's the same as Ashley and Charlie. Charlie and Brian, that's the same as Brian then Charlie. And then we have David and Ashley, that's the same as Ashley and David. David and Brian. Oh, whoops, this should have been a C. So now we can count how many that we have left over. We have 1, 2, 3, 4, 5, 6. Oh, this one should have been crossed off too, I'm sorry. Because David and Charlie is the same as Charlie and David. So we have 6 different options now. Because the order did not matter. doesn't matter which person was picked first. They're getting the same. They're getting the same quiz. So this is called a combination. So a combination is a selection of our objects from a group of n objects where the order is not important. So order is not important. That means it is a combination. Like if you said, "Hey, over summer break, I'm going to play 3 video games." Okay, does it really matter which order you play them in? In most cases, not. Unless you're playing like a trilogy, then yes, the order would matter. But if you're just picking 3 random games, no, it doesn't matter what order you choose to do those in. So a permutation is, the formula is NPR, where order matters in a permutation. And in a combination, the abbreviation for that is NCR, and this deletes duplicates. And we use this, order doesn't matter. So without calculating which one of these would be larger, so the way you would read these two things here, 8p6 means I have 8 objects to choose from, and I'm picking 6 of them. And over here, the same thing for combinations, that I have 8 things to choose from, and I'm picking 6 of them, but the order doesn't matter. When the order matters, you're always going to get more options. Look at our example up here. When the order mattered, we had 12, and then when the order didn't matter, we went down to 6. So a permutation will be larger. Now, some keywords to look for permutation if you're trying to figure out orders of a race, or if the word says order, or if you're filling specific roles. Like, all right, you have a president, vice president, and secretary. How many different ways can a group of students be selected or elected to those roles? And then keywords for combinations. If you see the word, combination, that is a good indicator that order doesn't matter. If you're talking about toppings on a pizza or on ice cream, does it matter on a pizza if say I want pepperoni, banana peppers, and bacon? Does it really matter which order you go in? No, it doesn't. They're all going to end up on the same pizza. So again, I know these formulas may look a little intimidating right now, but they're really super easy to calculate because we're just going to use the button in our calculator. So let's look at the next page. So we have a standard deck of cards that has 52 playing cards in it. There's 4 suits and 13 different cards in each suit. How many different 4-card hands are possible? So if we're thinking about this and trying to reason here, if I'm giving you 4 cards, does it really matter which one I gave you first? No, it doesn't. So that tells us this is a combination problem. And how we would write that, we'd write 52 C 4. Now the 52 is how many options or choices or objects, how many objects to pick from. So in this case, I have 52 cards to pick from. The 4 right here is how many I'm taking, or how big the group is. So in this case, I'm taking, I want a group of 4. I'm taking 4 cards. So I have 52 cards in the deck, I'm picking 4 of them. Now in the calculator, I'm going to write down the steps, and then I will show you in the how to do it. So we're going to type in the number 52 in the calculator. Then we're going to press the math button. From there, we're going to press over to the PRB menu like yesterday. And then go to NCR. And then you're going to type in the number 4. So let me show you what that looks like. Here, I'll move this. Okay. So 52. There we go. 52, then math. Then I'm going to go over to PRB all the way on the right. And you see the third one down says NCR. Hit enter. And then 4. And that's how many different possible hands there are. Now you might have seen in the math menu the NPR for number 2. Well, when we do a permutation problem, that is where we will go to. So this one, there are 270,725 possible hands. The hardest part about these problems is to figure out, hey, does order matter? And then deciphering where what the numbers mean. How big are the groups? How many do you have to pick from? And so on. The next one, number 2, when you order a meal at a local restaurant, you can choose 2 of 13 available side dishes. How many different combinations of side dishes are possible to accompany your meal? When I go to Logan's with my grandparents, you always get 2 sides. Now, does it matter if I say I want fries and then green beans? And then is that different than saying green beans and fries? I'm going to get both side dishes anyway, so it doesn't matter which one I chose first, I'm going to get both of them. Personally, I go with mashed potatoes and fries, because that's just what I like, but I could have said fries and mashed potatoes, and it means the same thing. Order does not matter in this one. So we have 13 options. So we have 13. This is a combination problem. And we choose 2 of them. So in the calculator, let me start over in the menu. We're going to do 13 math over to PRB. Go down to NCR 2, and we get 78. So 78 combinations. All right, number 3. A yogurt bar offers walnuts, raisins, blueberries, granola, and honey as toppings. How many ways can you choose 3 toppings? So first, let's see how many we have. We have walnuts, raisins, so 1, 2, 3, 4, 5. So we have 5 to pick from. Now we got to think about it. When you're putting toppings on your ice cream, does it matter what order you go in? No, it really doesn't. You might say, well, yes, it does, depending on the topping. No, generally, it doesn't matter which order you put the toppings on, it's all going to go on the ice cream. It doesn't matter which topping you told the ice cream place first. You're going to get all three. So order does not matter. So it'll be 5C3. When we type that in the calculator, we get 10. Let's look at number 4. The Springfield School Board has 7 members. The board must have 3 officers, a chairperson, an assistant chairperson, and a secretary. Hey, how many different sets of these officers can be formed from this board? Well, you may be thinking about yesterday, said, wait a minute, can't we just do 3 blanks in 7 times 6 times 5 because we have 7 different options for chairperson, and then that would mean 6 options for vice chair because the same person can't hold both chairperson and assistant chairperson. And then that means 5 for secretary because you can't have the same person hold all 3 offices. And you multiply that up and get 210. And I say, yeah, you could do that. That will work. You could also use a permutation. The order does matter in this one because we have 3 different positions, a chairperson, an assistant chairperson, and a secretary. So order does matter. So this one would be 7P3. And if we type that into the calculator, we get 210. So we get the same thing regardless. Some people, this makes more sense to me personally because I can see this better, but there is nothing wrong with this way either. All right, letter B, how many 3-person committees can be formed from this board? Well, a 3-person committee, that's just the order doesn't matter from your selection. It's kind of like when all the Algebra 2 teachers get together. It doesn't matter who was picked first. We're all Algebra 2 teachers. So how many 3-person committees can be formed? This one, the order does not matter. So 7, combination 3. And we type that in the calculator and we get 35. Alright, number 5. You're in a soapbox racing competition. In each heat, 7 cars race, and the position cars are randomly assigned. How many ways can a position be assigned? So we have 7 cars, 7 positions, and they're all randomly assigned. So we're going to pick all of them. They are randomly assigned. So none of them are being left out. So if you were doing it permutation-wise, it'd be 7P7, which is 5,040. Or you could write out little spaces, 7, 1, 2, 3, 4, 5, 6, 7, and say, okay, I have 7 choices to go in the first spot, and that means only 6 options to go in the second spot because a race car can't be in the first spot and second spot. And then you could do this, and you would also get 5,040. So it doesn't matter which way you do it. Number 6. 4 people have been working on a group project. Your group has decided to have 2 people present the project together. How many combinations, there's a key word, of 2 people from this group are possible? So we have 4 people in your group, and you're choosing 2 of them to go up and present. Now, it doesn't matter which one goes up first or which one was picked first to be in the presentation group. So that is why it's a combinations problem. And when you type that in the calculator, you get 6. Okay, so again, the hardest part about this is really figuring out if the order matters or not. Do not get flustered by this weird notation 4C2 or 7P7. I know it's really different than what we're used to, but just remember what it means up here. This is kind of a good thing to refer back to, right? So hopefully this made sense. And if you need help, reach out, ask me. Make sure you like the video and subscribe if you haven't already.